Today we are going to install Enzyme version 1.1 on a Raspberry Pi 4 with, I think it's a 4 gig RAM version of it. It's here in my local network. It's actually sitting right next to me. And yeah, we're just going to walk through it. So in case if you get stuck anywhere, I hope you can use this and kind of see how it works. And I think this shouldn't take too long. We're going to start with a Raspberry Pi that I have pre-configured, as in there is a Raspbian on it, and I did all the standard stuff. I set a different password, enabled SSH, set the time zone, set the local, set the keyboard layout. But besides that, I have not done anything yet. This is also the Raspberry Pi or the Raspbian, or I think it's called Raspberry Pi OS now, light version. So it doesn't come with a lot of things installed. It's completely headless. And we're going to use 4 Wi-Fi adapters. They're going to be 4 Panda Wi-Fi adapters. You can do this with 1, you can do it with 3, you can do it with 2, completely up to you, but we're going to do it with 4 today just to show a little more how that would work, how you split up the channels, all of that stuff. The goal for this guide, I think today, is to end up with a enzyme that you can access and an enzyme that is collecting Wi-Fi frames, and then from there on, everything else is follow-up guides. I'm going to set this documentation here to the dark mode. That's going to make it a little easier to see. Yeah, once we're done with this, I guess you just dive in, and I think the next good kind of thing to look at would be the network monitoring part. We're not going to cover that today. We really just want to go and get a enzyme running on a Raspberry Pi. So let's get started. I'm going to SSH into it. Here we go. And this is a test setup, so I have really simple passwords. This is not meant for production in the end. We're going to keep it really simple. Okay, so we got to start and we got to install the dependencies. What we're going to do is we're going to update the local package information, and then we're going to install a few packages here. We're going to install libpcap. Pcap is for packet capture. That's an underlying library that we're going to use to actually read the data of the Wi-Fi adapters. We're going to install OpenJDK 11 for Java. We're going to install PostgreSQL 11, and then also wireless tools. Wireless tools are includes, for example, IWconfig. There's a new way of doing it with just, I think, cool tools just called AW. I still like the old way of doing it. I think it's a little easier, so we're going to install that as well. So I'm going to copy this and we're going to run it. Okay, we had to speed this up a little. I'm on a hotel Wi-Fi actually right now, and it's not the fastest, and that took a while to download. This should, I guess, in every normal kind of internet connection, this should not take longer than maybe 30 seconds or so, but we're almost there. Give this just one more moment, and then we will have installed all the dependencies that we need to run Enzyme on this Raspberry Pi. Almost there. Come on, almost there. There we go. Done and done, literally. Cool. So that means that the Raspberry Pi is now ready to actually run Enzyme. So what we got to do next, step 2, download and install Enzyme. So we're going to go to the downloads page of Enzyme, and we're going to pick the Debian package. We're going to copy that link, and we're going to wget it. That simply downloads it from that URL on here. And I am pretty sure that we'll also have to speed up this one a little bit. That's probably also going to take a good while. This should also, in any, it's actually not too, no, that's hotel Wi-Fi. Let's speed this up a little. All right, here we go. So that's installed. So what we can do next is this command here, dpkg-i. Basically, dpkg is the underlying Debian-based package manager. That's what I will call it. It's basically the tool that you use to install a dep package. This is, I'm not 100% sure, but I'm pretty sure enough to say it here, that this is what is running if you use the apt or apt-get package manager. I think that is simply wrapping dpkg. -i tells it to install a package. So what we're going to do, and we have to run it as root, so we're going to do dpkg-i enzyme 1.1.1.dep. That's it. You just installed Enzyme. It's not running yet because we got to go to the third step first, which is to configure our Wi-Fi adapters. If we look at iw-config, you see this here, that's the example. iw-config is like an if-config except specifically for wireless adapters. So if we run that, you'll see we have 3 network adapters here. The local loopback interface, not wireless, fine. ETH0, also no wireless extensions. That's right. Those are both just standard Ethernet network adapters. And then we got the WLAN 0. That is the onboard adapter on your Raspberry Pi. We're not going to use that. You can technically use that if you don't want to use an external connection. There is also, if you do not want to use a cable to connect your Raspberry Pi to your network, but you want to use your Wi-Fi adapter, the onboard Wi-Fi adapter for that, there is in the knowledge base here, there's an article that shows you how to still use that and not interfere with the actual network adapters that you want to use to monitor the Wi-Fi environment with Enzyme. Just keep that in mind. In this case, we're cable connected. So you actually see here, we got a normal Ethernet cable, but again, if we run iw-config, you see that the onboard Wi-Fi adapter WLAN 0 is not connected to anything. We're going to completely ignore that thing today. So what I'm going to do now is I'm going to plug in the additional Wi-Fi adapters, and then we're going to run the command again. So just 1 second. All right, so those are all plugged in now. So if we run iw-config again, we should see much more output. Here we go. So you see, additionally, we got WLAN 1, 2, 3, and 4. The reason we're not using the onboard adapter is simply that out of the box, that thing doesn't support monitor mode, which we need. There's no way to put a better antenna on it. And it's just a little messy. If you can, always use one of the, if you look here at the requirements, always use one of these supported Wi-Fi adapters. There are others that are supported. These are those that are recommended. I'm actually using today the PAU05 and also PAU, I believe, 07. So I plugged a bunch of these in right now. So now we see that we got 5 in total. We, however, because the problem is that we cannot rely that when this system comes back up, that it keeps the same order. We cannot rely on that really. So we want to have better names for these. And what we can do is we can decide to assign predictable interface names. And all we have to do, this is explained here in a little more detail, but all we have to do on a Raspberry Pi is we have to delete this file and restart the system. So in etc systemd network, there is a file or a symbolic link called 99-default.link. If we delete that, so simply rm etc systemd network 99-default.link, which I can't because I'm not root, so we're going to sudo rm it. Here we go. Now if you restart the system, remember how they're called WLAN 1 to 4 right now. Now if you restart the system, I'm going to give this just a moment, and they're going to come back like, let's see. I don't have an example in here. Here. They're going to come back like this. And what you see is that the MAC address of the adapter will actually become part of the name. And this way we can be sure that no matter in which order you plug them in, if you unplug one or whatever happens, or if the kernel simply decides to move the order around, you can always clearly address one of these, which is important if you want to, let's say, for example, you have one adapter that supports the 5 gig spectrum and the other one doesn't, you want to make sure that you can address them properly. So now this one should have come back by now. Here we go. Let's run iw-config again. You see this here. And you see it already happened. The onboard adapter is now WLAN 2. That was WLAN 0 before. So very confusing. But we don't care about this one. We only care about the others. And you see that they are now named WLX. And then they simply have their MAC address behind them. So that is going to stay predictable. Do that. It's called predictable interface names. Very, very, very good idea. Okay, we're going back to the main installation. So we just did this part here. So we're pretty good with that now. We could go on with setting up Postgres as a database. Just wanted to show you one thing here real quick. You see here that the mode is set to managed for all of these right now. We want to end up having this mode set to monitor. That simply means that they're in monitor mode, and that means that they are basically reading everything that they receive on the air, and not only what's being addressed to them. Very similar, I would say the equivalent is the promiscuous mode of a standard Ethernet adapter that you might be familiar with. We got to do that so that Enzyme can actually properly read the frames of the air. But I'm going to do that in a second. In fact, Enzyme is going to do that automatically for you. So now we got to set up our database. We did in the step before, we installed Postgres already. That will by default only listen on the local host, so we don't have to do very much about that right now. There's no risk that others can connect to it from the outside. We're going to run this command here. What it basically means, run the psql command as the user Postgres. That will always give you a Postgres shell as a system user. We're going to go in, we're going to create the database Enzyme. See, it returns create database, which means it has created a new database. We are going to create a user and give it a password. And again, this is just a test setup, so I'm going to give it a really stupid password, 123.123.123. Please choose a better password here when you do this. So we created a user, and now in the last step, we are going to grant all privileges on the database Enzyme to the user Enzyme that we just created. So what we have now is we have a new database called Enzyme, and we have a user with the password 123.123.123 that has all privileges on that database. And that's all we got to do. Control D out of it, or \Q. We're back in our normal Linux shell. So now we can go further and we can configure actual Enzyme. The Enzyme package ships with a configuration example file. That's an etc enzyme, enzyme.conf.example. So what we're going to do is we are going to copy this to where Enzyme expects this configuration file, which is etc enzyme, enzyme.conf. And then we are going to configure a few parameters. So etc enzyme, enzyme.conf. Here we go. So this is our standard Enzyme configuration file. I'm going to make this a little larger. I'm also going to open a new shell here because we're going to have to run a Linux command in just a second. So I'm not going to go through all of these right now. They're documented in the documentation. This would simply take too long, but we have to set a few of them right now. And we're going to do this as root to actually be allowed to write any changes on it. Here we go. Okay, so we will have to set the admin password hash. That is basically your admin password that you're going to use. Enzyme does not currently ship with a full user model, so you have to configure a hard password here in that configuration file. That's going to change in the future. For now, that's what you got to do, though. However, we never want to store actual plain text passwords, so what we're going to do is we're going to store the how do you pronounce that in English? I never thought about it. The SHA-256 sum. It's basically a hash of it. We can generate that. You can generate that in any way. However, there's a very easy way to do that, which is to simply use the SHA-256 sum command. So what we can do is we can type on any Linux shell, echo -n, and then whatever you want to use as a password. Again, so I'm going to use 123.123.123 and pipe that into the SHA-256 sum command. The -n is important because -n here for echo means no new line, because if it would append its standard new line after this, then that new line would become part of the hash and you wouldn't be able to log in. I'm going to run this. It's going to return this. Do not copy this dash. Only copy this part. That's your hash sum. We're going to copy that. And we're going to insert it here. So now I will be able to log in with the username admin and the password 123.123.123. We have to connect our database. So that's a standard database path. You see here, it's going to be it's a Postgres on localhost port 5432/enzyme. That's the database that we created. And then you see these parameters here, user equals enzyme and password equals your password. Remember that we set that to 123.123.123. And I think that should be it to just get it running. However, we also want to connect our monitors, so the Wi-Fi interfaces that we're going to use. Remember these 4 that we created earlier? We definitely want to put these in here. So I'm going to do that with just 1 right now. So let me remove all these comments here. That's going to make it a little easier to read. And then let me log back into the Pi on my second shell here so that we can run iwconfig. And we're going to pick the first one here. That's its interface name. And we're going to put it here in the device name. Okay. Right here. That will be enough right now because we can leave everything else on standard. I wanted to cycle through all of these Wi-Fi channels. That's a bunch of the standard 2.4 gig frequency band here. The channel hop command, I never had a reason to change that. It's documented what exactly that does. Hop interval is fine. And these adapters are pretty well supported, so we don't need to set skip enable monitor either. That's also documented in the documentation. We're not caring about that today. And we are also not setting up any network monitoring yet, so we can take that one out. And you can also read more about that in the documentation later. Again, the goal here today is only to get it running. Okay, let's see what else this said. We did set the database path. We don't have to change any of the other stuff. So we can go to step 6, which is to start Enzyme. What we're going to run is we're going to run system control enable Enzyme. What that does, let's run it. Here we go. What that does is it basically tells systemd or the system here to always run Enzyme when the system starts up. It is, however, not started yet. So if we go to status Enzyme, you'll see it's not running. You see it's loaded, but it's inactive, and the preset is enabled. That's what we just did, which means basically that it will run on startup. So all we got to do now is we got to run system control start Enzyme. Let's run status again. Here we go. You see it's active and running. That's what we want to see. And now to confirm that it is actually running, you see we did the same thing here. We want to look at its log file. So let's do a tail-n200, so the last 200 lines, -f, so follow it, print every new line that's being written, of var log enzyme, enzyme.log, and we do have an error in our configuration file. Let's see what it says. Okay, we have, so that's interesting. This here is our error. It's not starting up because it says our parameter general.python.path does not point to an executable file, user bin python 3.8. So let's look at that configuration. And you will see that we have python.path, in fact, set to user bin python 3.8. Looks like it doesn't exist. So let's do user bin python. Yeah, see that? We got a Python 2.7 and a Python 3.7, but not a Python 3.8. So what we're going to do is we're going to change this up. I should probably actually fix this in the documentation, or at least in the standard config file here. Here we go. So we're going to set this to Python 3.7, which it should find now. And we're going to do a system control restart Enzyme. That restarted it, and then we're going to look at that log file again. And now it's doing more already. There we go. All right, it's fetching its list of OUIs. It's always going to take a moment, especially with this slow connection that I have here, but that's fine. One last thing that we're going to have to do is we're going to have to set its listen address because right now Enzyme by default is only listening on the local host. So I would only be able to access its web interface and its API from the actual Raspberry Pi, but I want to connect to it from anywhere in my network, especially here from this laptop that I'm on. So the important thing that we're looking for here is that it has built a PCAP handle on that interface that we connected, and that it has acquired that PCAP handle, and that it's already cycling through these channels. So I'm pretty sure that it is in fact already collecting Wi-Fi frames for us and does its thing. So now however, to access the web interface, we got to change its listen address. It's currently only listening on 127.0.0.1. We're going to change that now. We got to change two things. We're going to change the REST listen URL and the HTTP external URI. So we got to set that to the IP address that I want to connect from. And that is, in our case, 192.168.8.159. So I'm going to copy that. And I'm going to put this in here. And we're also going to set it to the external URI. Also not going to go into much detail about what the difference between the listen URI and the external URI is. That only is important if you have a load balancer, if you use proxies, stuff like that. Documented here in the actual configuration file and also in the documentation. Out of scope here for now. So if I restart Enzyme now, it will start listening on this address here. HTTP 192.168.8.159 on port 22,900. You can set that to really whatever you want. But 22,900 is the default. So same thing, restart Enzyme. Open that log file. It's starting back up. And we're going to wait for it to say that it has started its web interface in the REST API. Should happen in just 1 second. There we go, it's doing things. There we go, you see this here. Started web interface and REST API at this address, that's what we configured. Access it here, so we're going to do that, and we're going to say, open that, please. And here we are. Here's our new Enzyme. So I can log in now with admin and remember the password hash that we set, 123, 123, 123. Please set that to something better. I'm going to wipe this whole system and throw it away after this demo. So please choose better passwords. I'm going to log in, not saving this. And here we go. You already see that this one probe that we configured, this one Wi-Fi adapter that we configured, is listening on all of these channels that we configured. It has already read a bunch of frames, and then I think that we will actually be able, here we go. That's all the networks that it found. And here, like I said, it's hotel Wi-Fi. It has started to collect data. Now it's doing its thing. That's all it took. With a faster Wi-Fi, I think that this would take probably about 20 minutes to set up. It should be pretty straightforward. If you get stuck anywhere, go to the help pages here on the documentation. You see here it lists if instructions are unclear in any way. There are community forums. There's a Discord. You can always join the Patreon, obviously. Just join the Discord or ask a question in the community forums. There will always be people, including me, trying to help you. I consider everything that's unclear a bug. So anything where you get stuck, please report that. Happy to help. And then that will also allow us to make this clearer in the documentation, easier in the product. But yeah, the next step here would be now to add more of the Wi-Fi adapters. So I would add 3 more of these probes. Remember, that is, we go page down, that is this part here, the monitors. I would add the remaining 3 devices here to it. You basically just copy that. So what's that? 1, 2, 3, 4, 5, 6, 7. You just add a second configuration here and just switch out the device name of it. Let's actually do that right now. Just to show you. Again, iwconfig, take the next one, put that one in here, restart Enzyme. You see that this is going to disconnect now. Here we go. It's restarting, so it should come back in just a second, and then it should have 2 of them. In fact, no, it will not. It will complain because we told it to listen on the same channels. Pretty sure that's what it's going to do. Yep, here we go. Channels cannot be duplicated per monitor or across multiple monitors. So let's switch these up. Let's have this one listen from everything from channel 1 to 6, and then this one here from channel 7 to 11. Restart that again, look at the logs again, and then it should come up with 2 of them. So you basically, why you want to have multiple adapters is that they can spend more time in a smaller set of channels, and that will simply make you record more data, and that will make Enzyme more useful. However, you could totally run that with just one adapter. I just happen to have 4 here because obviously I use a lot of them all the time. But we should now see the second adapter pop up in here. You already see that it's now processing on 2 adapters. We would have 2 more to add. Let's log back in. 1313123. And here we go. You see now we got 2 adapters running already, and that also, you see it all almost doubled here immediately in the number of frames that were recorded. So we're simply looking at at more data because we have more adapters that can spend more time per channel while they're cycling through all of these channels, and everything is here. And I think that's it then. Like I said, if you get stuck anywhere, community forums, Discord, please let us know about it so we can make it better and help you. And now you got a Enzyme running on a Raspberry Pi. Thank you very much.